Video in the problem solving series, where I take you through my methods and tips and tricks to solve actual IB style questions. Today we'll be looking at a problem from 8.1 kinematics. So this question says a ball is initially 50 meters above the ground. The ball is thrown vertically upwards and takes 5 seconds to reach the ground. Air resistance is negligible. What is the initial speed of the ball? Alright, so we're given the time as 50 seconds, so t equals 50. And we're given that the acceleration is obviously g. In paper 1 we can call it as 10, so we say g equals 10. And now what we're looking to find is the initial speed. Okay, we're also given something to do with distance here, right? So we can't directly substitute s equals 50, but we know that this has something to do with distance. So let's think about it. S is the initial height. That means that what we're looking at is something that starts off at 50 meters. So let me just draw that really quick. So this right here is 50 meters. And the ball goes something like this, right? Or because it's thrown vertically upwards, it can also go like this. We don't entirely know. But it's one of these two, and it doesn't really change the final answer because we're not asked to find horizontal distance. So what is the initial speed of the ball? Okay, so let's think what equation we need to use. We have s, we have g, so that's a, and we have t. So we can write s equals ut plus half a t squared. Sorry, it should say t is 5.0. I forgot a decimal point there. But if you think about it, our initial height is 50. After that, the ball goes up and then falls back down. So we can't say that s is equal to 50. That would be very wrong. So let's rewrite this as a function of itself, right? So we'll call this 50 as s0, which represents that as the initial state. And we'll say s is equal to s0 plus ut plus half at squared. Like that. So what I've done here is basically split this distance s into two parts, s0, which is this 50 right here, and s, which is the rest of it. Now let's take the velocity at the end point. The height at the end point. At the end point, we know the ball falls to the ground. So this s here is 0. That must mean that s0 we know is 50. T is 5, so plus 5u. Plus half times 10 times 25, because that's 5 squared. So if we solve for this, we have 0 equals 50 plus 25 times 5, because 10 by 2 is 5. So 25 times 5 is 125. So let's just write it as 125 plus 5u. So now, oh sorry, wait, I made a mistake here. So acceleration is downward, so it has to be defined as negative. So it's actually minus 125. That was an oversight by me. I'm really sorry. So now we have 0 equals to negative 75 plus 5u. And if we rearrange this, we get 75 equals 5u. So dividing by 5 on both sides, we get 15 is u. So the answer is option B. So this is one of the hardest kinematics questions you will get. If you're able to solve this and you got it right on the first try, congrats! I hope this video was helpful to you, and please check out some of the other videos on the problem solving series.